You are given a resistor in the shape of a rectangle. You're told the cross-sectional area is A, it has length L, and resistivity is rho sub C. You are to find an equation that describes the resistance of this structure. As always, we start by drawing a figure. So here's the resistor with the voltage applied, and so there's a current I flowing. So with this applied voltage, we need to find the corresponding current, and the ratio of the voltage to the current will be the resistance we're looking for. The electric field inside the resistor will be constant, and it will be in the x direction. So the voltage we're applying, which is the potential at 0 minus the potential at L, will equal minus the integral from L to 0 of E dot dl. We substitute in our electric field intensity. E sub x is a constant that can go to the left of the integral, and the unit vector in the x direction dotted with dl will give us dx. So the voltage across the resistor is equal to the electric field intensity inside the resistor times the length of the resistor. Since there's only an electric field intensity in the x direction, there will only be a current density in the x direction, and it will equal the conductivity times the electric field intensity, or the electric field intensity over the resistivity of the material. The current flowing will just be the current density times the cross-sectional area, and for the current density we can substitute the electric field intensity divided by the resistivity. For the voltage, we'll substitute the electric field intensity times the length of the resistor, and for the current, we'll substitute the electric field intensity times the cross-sectional area divided by the resistivity. We can divide numerator and denominator by E sub x, and we get our result for the resistance of this rectangular-shaped resistor.